Okay, kids, so in this unit, we're going to be working on similarity. All right, we're going to start, all right, by talking about methods of proving triangles similar. Now, what does similar even mean? So, similar triangles are triangles with corresponding angles congruent Oh, does that mean that they're congruent? Well, not necessarily, because here's the difference. So you're going to have corresponding angles congruent, and corresponding sides are not necessarily going to be congruent unless it's a 1-to-1 ratio. Okay, so corresponding sides are in proportion. In proportion just means they have equal ratios, okay? So in proportion means that the corresponding sides have equal ratios when you compare one to the other, okay? So you would do small to small, medium to medium, large to large. All right, so the first method of proving triangles similar is angle is congruent to angle. Now you can write it like that. I will also accept angle similar to angle, even though they're congruent, just because you might find it confusing to write congruent. All right, so let's look at an example. So let's say I have these two triangles, right? I have this one triangle, and then I have another version. It's going to look like a smaller version. Well, are these similar or not? Because as you know in geometry, the spirit of this entire course is about whether or not you can assume things, right? So let's say that the measure of angle A is 75 degrees, and the measure of angle C is 31 degrees. And then let's say the measure of angle D is 75 degrees, and the measure of angle F is 31 degrees. Well, we're being asked, are these triangles similar? So the answer would be yes, they are similar, because here's what you need to have. The requirements are you have to have two pairs of angles which are congruent to one another. Okay, which is what we have here. So these are similar. The triangles are similar. That's the symbol for similar by angle. Similar to angle. Okay, now what if I don't give you the actual measurements, but what if I give you a picture like this? And I ask you, are these triangles similar? So let's call this WVX and YZ. Okay, so let's say I tell you, okay, these lines are parallel, right? If those lines are parallel, that's all I need to give you in order for you to prove that these two triangles are actually similar. Because you remember the Z's, right? So when lines are parallel, when you have parallel lines, the alternate interior angles are congruent, aren't they? So that means angle W would be congruent to angle Z. Now you can use vertical angles if you want, or we could do another Z. It's up to us. So these angles are also congruent. So we have two pairs of congruent angles. So yes, the triangles are similar by angle. All right, a second way to prove, so these are methods of proof, we're going to be doing proofs, to prove that triangles are similar is the side, similar to side method. Okay, what does this mean? Because it's not congruent. All right, let me put these in 3 different colors. It means that the pair of red sides have the same ratio as the pair of blue sides, which have the same ratio as the pair of green sides. All right, so let me draw a picture here. So let's say I have this triangle. Okay, then I have this other triangle. I'll call this QPR. And I'll call this TSU. And I give you the measurements of the sides. So I say, okay, this is 3, this is 4, this is 5. And then this is 6, this is 8, this is 10. So you may want to use highlighters for this. I'm going to color code it. Small to small. Medium to medium. Big, largest to largest. Okay, let's look at these ratios. So I have 3 to 6. Then I have 4 to 8. And then I have 5 to 10. Are these ratios all equal? Well, yes, they are. So that means that these two triangles, okay, so triangle QPR is similar to triangle TSU by side, 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 similar to side, side, side. The last method to prove triangles are congruent is side angle side, similar to side angle side. Okay, what in the world does this mean? Well, let me color code the sides. So it means that you have two pairs of sides in proportion. This one is the most confusing one. So you have two sides in proportion, two sets of sides, I should say. Okay, two sets or pairs of sides in proportion. Okay, but then the angles are congruent, the angles between those sides, with the angles between the proportional sides congruent. Okay, so let's look at an example. All right. So in this picture, I have two triangles. Now I'm going to separate them for you, and you might want to get in the habit of doing this. Okay, so in math, one of the things we do is we differentiate, right? Differentiate for all different learning styles. Some kids don't need to separate these. Other kids do. Just have to know yourself, guys. So if you find it too confusing seeing the two triangles, then you're going to want to draw them separate. So if I separate them, okay, it doesn't even have to look nice. As you can see, mine looks ugly. Okay, but you know, one of the reasons I make these videos, guys, and they're not perfect, is because I want you to see that I'm human, just like you. Things do not have to be perfect. All right, so I have 15, 12, and then I have 25 and 21. All right, so let's color code this. So I'm going to have, all right, small to small. And then I'm going to have these larger sides to one another. Okay, so the angles in between. Well, angle A is between. Well, look at angle A. It's congruent to itself, isn't it? Angle A is congruent to angle A, reflexive. So things from the previous proof unit will come up in this unit as well. Okay, let's look at the ratios. So we have 12 to 21. Is that the same as 15 to 25? Now you may want to cross multiply. I'm just going to write the proportion this way. So I have 12 to 21, 15 over 25. You could also reduce these, by the way. So, like for instance, I could divide the first pair of fractions by 3 and get 4/7. And then the second pair of fractions by 5. And then that would give me 3/5. Okay, these are not similar because these sides are not in proportion. So the answer is no, they are not similar by side angle side. Okay, if these sides had been in proportion, then I would have been able to state that the triangles were similar. Okay, so let me show you a triangle proof. We're going to spend more than one day on this. I'll be adding on to this in the next lesson. All right, so let me draw a picture. These pictures are not very favorable looking, I'm just letting you know. So in this picture, ask yourself how many triangles are there. Okay, your answer should be that there's 2. And in a couple minutes, I will draw them in the same position if you find that easier. So let's look at the given. So we have given. We have that AB is perpendicular to BC. And then we have ED is perpendicular to AC. Okay, we're going to prove that triangle AED is similar to triangle ACB. Now I'm going to draw these 2 triangles so that they have, they're in the same position. So let me just draw this triangle over. And you definitely may want to do that in this picture. I think most students, most people would have difficulty understanding this problem if they didn't draw it out. So I'm drawing the larger triangle. Now when I draw the smaller triangle, A is, let me first draw a smaller version that looks similar. A is going to be where A is. And then the angle C is going to be where my angle, my angle E is going to be where my angle C is. And then my angle D, okay, will be where my angle B is. So these are in the same position, okay? So let's do the proof. So we have statements, reasons. Okay, in this video, I'm just going to do one proof. So I know it's a lot to watch proofs. So number 1, you put the givens. AB perpendicular to BC. ED perpendicular to AC. Given. Okay, so by now, you know from the previous triangle congruency unit that perpendicular lines give us right angles. So angle B, and now I can't call this angle D. So this angle D, I have to name it with 3 letters. Even though I drew it separately down here, I still would have to name it angle ADE. Are right angles. Because we need to know what angle you're talking about. It has to be in that triangle. So you have to look at this picture to name your angles, okay? All right, so perpendicular lines form right angles. Okay, so then after this, we can say that those angles are congruent. So angle B is congruent to angle ADE. All right angles are congruent. Well, where are we going to get something else? There's no numbers involved or anything, right? So again, we have reflexive, kids. So angle A is congruent to itself. So for number 4, we have angle A is congruent to angle A, reflexive property, okay? And then we can say that the 2 triangles are congruent. So we have similar, sorry guys. Triangle AED is similar to triangle ACB, and the method of proof would be angle, angle, similar to angle, angle. Okay guys, that concludes this this lesson, and I will post the flipped work for in class. Thank you.